Hi and welcome to Axiom Chemistry. In this video, we're going to talk about the kinetic theory of matter. But first, let's review what we've discussed about particles in solids, liquids and gases. We've seen that those particles are always moving. So in solids, the particles can vibrate. In liquids, the particles can slip and slide over each other. And in gases, the particles can move in all directions. So in summary, we could say that all matter is made of tiny particles which are moving. Now, the kinetic theory of matter describes this movement in a little more detail, and we're going to be exploring it by thinking mainly about gases. So let's just remind ourselves in a bit more detail of their movement. So as you should remember, in gases, particles are spread far apart, so something like this. You can see they're also randomly arranged. Also, particles move in all directions and fill the available space, so something like this. Now that's how particles of a single type of gas might move. How about if we had two different gases? Well, let's take a look at a simulation which shows two different gases. I'm going to remove that barrier and I want you to watch what happens to the particles. Now, because all of them are moving randomly, they gradually start to mix. It's hard to predict exactly how each particle will move, but overall you can see that the particles are mixing together. It's really important that you understand that, so let's go back to the beginning of the simulation. Here it is with the barrier. Take the barrier away and you can see that that random movement is causing the particles to mix. We call that mixing of particles caused by their natural random motion, diffusion. So let me now show you a video of real particles diffusing. In a moment, you're going to see some blue ink being injected into the top of that box. Here it comes. Now it's being injected, so it's moving downwards quite quickly, but you'll see that it's not just moving downwards. It's also moving sideways. In fact, the particles are moving in all directions. And if you leave them long enough, those blue particles will eventually spread throughout the entire box. And this is just one example of diffusion, because remember, diffusion is the intermingling of substances by the natural movement of their particles. So now let's think about diffusion at different temperatures. These two simulations here show particles which are exactly the same, except that the ones on the right are hot and the ones on the left are cold. And you can see that the hotter particles mix much more quickly than the colder ones. And that's because they've got more energy and they're moving faster. And that leads us to a second observation, which is that particles move faster as the temperature is increased. So let's add that to our list. There we are, particles move faster as the temperature is increased. Now finally, let's think about what would happen if we mix different types of particles, this time at the same temperature. Let me show you two more simulations. The one on the left shows particles which are small and light, and the one on the right, particles which are relatively large and heavy. Now, once I remove those barriers, you can see that the small, light particles mix much faster than the larger, heavier ones. And that's because they're moving faster. So we can add that to our list of observations. So here we are. At a given temperature, smaller and lighter particles move faster than larger and heavier ones. And those three statements, together with our observations of particles in solids, liquids and gases, are the essence of the kinetic theory of matter. As ever, here is a summary of what we've discussed in this video. We've seen that the kinetic theory of matter states that all matter is made of tiny particles which are moving, that the particles move faster as the temperature is increased, and also at a given temperature, smaller and lighter particles move faster than larger and heavier ones. And we've also seen that diffusion is the intermingling of substances by the natural movement of their particles. Now, if you haven't yet written any of that down, I suggest you pause the video and do that now. Well done, and see you in the next video.